Today we finish off combinations. It's part 2 of combinations, section 2.6. So let's get right into it. How many different 5-card hands can be formed containing at least 3 black cards? And this is what separates or distinguishes these part 2 questions, is they ask things like at least 3 black cards or at most 3 black cards, like that. So you have to do multiple steps here. If you have a 5-card hand and it could have at least 3 black cards, well then what could you have? You could have 3 black cards, 3 black, and you need a 5-card hand, so you'd need 3 black and 2 red, right? But what else could you have? You could also have 4 black, and then you'd only have 1 red. Or you could also have 5 black, and in that case you would have no red. So you're going to have to consider all those situations. Now, you can have this situation, this first one, or you can have the second one, or you can have the third one. Wow, or, what does or mean? That means add. So let's take a look at this. 3 black, 2 red. How many black cards are there? There's 26 black cards. And we want to choose 3 of them. And we also, so this is a multiplying, we also want to choose 2 red ones. How many red cards are there? 26, and we want to choose 2. So we have to do all that to figure out how many combinations there are of 3 black and 2 red. If you do that, 26 choose 3 is 2600, and 26 choose 2 is 325. And if you multiply those two together, you get 845,000 different combinations. Now for the next one, 4 black. Well, there's 26 black cards, you're choosing 4 of them. There's 26 red cards, you're choosing just 1 of them. Going to multiply those together because you need to do both those things. 26 choose 4 is 14,950. 26 choose 1, you shouldn't need a calculator for that. If you have 26 things and you want to just choose one of them, then there's 26 different options, and if you multiply those you get 388,700. And finally, if it's choosing all black, it'd be 26 choose 5, and then you'd have no red, so it'd be 26 choose 0, or you can just ignore this step because 26 choose 0 is just 1. So you'd have 26 choose 5 is 65,780 times the 1, so you still have 65,780. And remember, what you're going to do is you are going to add these 3 amounts together, and if you do that you get your final answer, which is 1,299,480. This is how many different 5-card hands there are which have at least 3 black cards. They could have 3 black cards, 4 black cards, or 5 black cards. Okay, wow. Next one. A planning committee is to be formed for a school-wide Earth Day program. There are 13 volunteers, 8 teachers and 5 students. How many ways can the principal choose a 4-person committee that has at least 1 teacher on it? Well, that sounds reasonable. You don't want to just trust students to be by themselves. You need a teacher to keep things moving properly, right? No, but I guess in this question you do. Okay, so 4-person committee, we need to have at least 1 teacher on it. Wow, this is a drag, because one way you could do this is you could have 1 teacher. I'm just going to put T for teacher, and you could also have, if we want to have a 4-person committee, 1 teacher and 3 students, or you could have 2 teachers and 2 students, or you could have 3 teachers and 1 student, or you could have 4 teachers. Forget about the students altogether, they just ruin everything. Let's just work with teachers alone. All 4 of those. Oh my gosh, you're going to have to figure out all 4 of these, and then since you could have this or this or this or this, then you're going to add together these 4 things. Man, is this ever a lot of work. I wish there was a faster way to do this. Hint, hint, foreshadowing. Think how you could do this easier. But anyway, let's do it this way first, and then I'll do it the easier way. So there's 8 teachers. Maybe the way I'll do it this, just to speed it up, is there's 8 teachers. So in this case it'd be 8 choose 1. In this case here it'd be 8 choose 2, then 8 choose 3, and finally 8 choose 4. And you're going to multiply each one of those by the students. There's 5 students. So in the first case it'd be 5 choose 3. and then be 5 choose 2, and then 5 choose 1, and then 5 choose 0. So if we do this, could certainly use a calculator. 8 choose 1, you know that one. That's 8. And 5 choose 3 is 10. So that's 80. 8 choose 2 is 28. And 5 choose 2 is also 10. And so you get 280. 8 choose 3 is 56. 5 choose 1, you know that. That's 5. So you get 280 again. And 8 choose 4 is 70. 5 choose 0. How many ways can you choose 0? One way. So just times 1, you get 70. You're going to add all those together, right? So plus, 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 560, 640, 710 seems to be the answer. Now, it wasn't that bad, but I'd already worked it all out with a calculator or whatever. If you'd had to use a calculator for all this, it would have taken quite a bit of time. There's actually another way you could do this. Did you think about it? I gave you all that time to think about it. If you want to know all the ways the principal could choose a 4-person committee that has at least one teacher on it, what's the only situation that doesn't work? The only situation that doesn't work is when you have no teachers on it. So what you could do then is consider all the combinations, the total combinations, or the total number of combinations, if you want, when there's no restrictions. And then what you're going to do is you're going to subtract the one that can't happen, that you're not interested in. That's combinations with 0 teachers. And if you get rid of, if this is the total number of combinations, and you get rid of the combinations you don't allow, the ones with 0 teachers, you'll be left with the ones that you do allow. So let's try that. The total number of combinations. So that is, if you consider all the volunteers, there's 13 volunteers, and you want to have a 4-person committee. So of the 13, there's no restriction whatsoever. So of the 13, you want to choose 4. Minus combinations with 0 teachers. Okay, so remember there was 8 teachers, and how many of the teachers do you want to choose? 0. So you don't even really need to do that. But what you do need to work with is the students. There were 5 students, and you want to, so multiplied 5 students, and you want to make the whole committee out of students, and there was 4 people on the committee. So 5 choose 4. Okay, 13 choose 4. Using my calculator, I could find that that's 715 minus 8 choose 0. You know that. The number of ways to choose 0 is 1 times 5 choose 4. You could actually figure that one out as well, but actually I'll save that and talk about it in a second. This equals 5. So you're going to get 715 minus 5, which is 710. And if you compare it, we got the same thing. I think this one was faster. I think this is a better way to do it. So you can't always do that, but sometimes it'll work. This here, the combinations with 0 teachers right here, this here is called the complement. This is the complement. It's kind of like the opposite, or the complement of the required outcome. Complement of the required is the part that's not required, the part that you're not interested in. And sometimes you can use this. The number of ways for the required outcome is equal to the number of ways with no restrictions, that's like the total number of combinations, minus, this is a very small, sad little minus sign here, it's a minus, the number of ways for the complement of the required outcome. So I don't know, memorizing this formula or whatever I don't think is really the way to go. I think the way to go is to just think about why did this work and how come this works in this case. Sometimes the formulas just make it more complicated than we're interested in. Okay, next one. This one's a drag. I hope you won't have to deal with questions like this, but I suppose you might. There's nothing really different about it. It's just, whether you use the complement or not, this one's just a lot of work. So there's 7 boys and 3 girls in the school art club. A group of 5 is needed to set up an art exhibit. How many different groups of 5 with at least 2 boys are there? So you could have 2 boys and 3 girls, or you could have 3 boys and 2 girls, or you could have 4 boys and 1 girl, or you could have 5 boys and 0 girls. Oh man, again, there's so much work. We got to do 4 of them this time. So you might think the complement's the way to go, but even with the complement, if there has to be at least 2 boys, then the complement, the ones we're not interested, the ones that aren't allowed, is to have either 0 boys or 1 boy. So you'd have to actually subtract 2 things in this case. Why don't we do them both? We'll do them quickly, and you'll see what I mean. So for this first one, number of boys is 7. So it's going to be 7 choose 2, 7 choose 3, 7 choose 4, and 7 choose 5, times, 13 girls, so it's going to be 13 choose 3, 13 choose 2, 13 choose 1, and 13 choose 0. And if you multiply those out, I'm just going to do it in one go here. So 7 choose 2 times 13 choose 3, I'm just going to tell you that whole amount is 6,006. Try it yourself, make sure you're getting these. 7 choose 3 times 13 choose 2 is 2,730. And 7 choose 4 times 13 choose 1 is 455. 7 choose 5 times 13 choose 0 is 21. And then because this is in this situation, or, you're going to add all those. So you'll be adding all these together. And the amount you get when you add, I want to save this space here. So the amount you get when you add is 9,212. Okay, you can do it that way. Or you can do it a different way. Another way you could do it is this. You could take the total number of combinations with no restrictions, right? And then you could subtract the ones that don't work. But in this case, there's 2 that don't work. The ones that don't work was when you have no boys. And how many girls would you have in that case? And 5 girls, I guess. Plus, the other ones that don't work is when you have 1 boy and 4 girls. That also won't work. So let's see, what would we do to get each of these? Total number of combinations, well, there's 7 boys and 13 girls for a total of 20 students, and we need to choose a group of 5. So 20 choose 5 minus. Okay, in this case, you have 7 boys, but you're choosing 0, and you have 13 girls, and you're choosing 5. Plus, the other ones that you're not interested in, so you need to take away from the total combinations, is when you have 1 boy, so that's 7 choose 1, times 4 girls, 13 choose 4. Okay, 20 choose 5 is 15,504. 7 choose 0 times 13 choose 5 is 1,287. I'm going to keep this in brackets. Plus 7 choose 1 times 13 choose 4 is 5,005. So now I have 15,504 minus, I add those together, and I get 6,292. And if I subtract those, I get 9,212, which is exactly the same thing we got up above. Okay, which one of those is better? I don't know. It's great if you understand them both. You don't have to ever use the complement. In this case, maybe you wouldn't use the complement, but in the one we did in the previous page, it'd probably be a lot faster to use a complement. Solve each of the following. What do you notice and why? All right, let's do this. I mean, you could just do this on a calculator. Let's do it without a calculator because I think it'll help us with the y part. So remember, the formula for combinations is n factorial over n minus r factorial, r factorial. So in this one, it would be 6 factorial over 6 minus 4 factorial, and then 4 factorial. Let's simplify. 6 factorial over 2 factorial times 4 factorial. Okay, on this one, well, yeah, we'll come back and finish that in a second. In this one, we have 6 factorial over 6 minus 2 factorial. That's minus 2 factorial, and then 2 factorial. So you end up with 6 factorial over 4 factorial, 2 factorial. Now, if you look at these right now, what do you realize? You're going to get the same thing, right? 6 factorial on top, and then on the bottom, multiplication order doesn't matter. You have a 2 factorial and a 4 factorial. You're going to get the same thing. So we could quickly get the answer here. You'd have 6 times 5 times 4 factorial, and the 4 factorials would cancel. So you'd have 6 times 5, 4 factorials cancel, and you'll have 2 factorial on the bottom, which is just 2. 30 divided by 2 is 15. So of course this one's going to be 15 as well. And as you can see, we have the same amount. Now, why is that? Well, there's a bunch of different ways you could think of this. One way you could think of it is because when you subtract 4 from 6, you get 2, and when you subtract 2 from 6, you get 4. Okay, that's good. Can you think of it just like if I draw 6 things? If I wanted you to choose 4 of them, why would that be equal to when I want to choose 2 of them? Because if I want you to choose any 4 of these things, say I pick this one, this one, this one, and this one. Another way I could have said, so these are the 4 lucky ones, let's say. These are the 4 lucky ones. Another way I could have said to do it is instead of choosing the 4 lucky ones, I could have asked you to choose the 4 unlucky ones. So choosing 4 of 6 is the same as choosing 2 of them, because instead of choosing the 4 you're interested in, we could choose the 2 that you're not interested in. Still not convinced? Let's prove it to you. Let's do a formal proof here. So this is, mathematically proving things. Here's the statement, first of all, that n choose r is the same as n choose n minus r, right? 6 choose 4, there's your n and your r, is equal to 6, there's the n again, n minus r, 6 minus 4 is 2. So this should work. How can I prove this to you? Let's just do the same thing we did here. This is equal to n factorial over n minus r factorial times r factorial. This one is equal to n factorial. Now you have to be careful here. It's n minus r, or in this case it's n minus r, and we need to put that n minus r in brackets. We subtract this, and we take away all that. And why don't I put a bracket, 10 million square bracket, factorial, right? Then what our second one would be is just n minus r factorial. Boy, those don't look alike, but they will once we simplify. This one just stays the same. This one, right here, n take away n. Well, n take away n is nothing, so that's gone. And then we have take away negative r. Take away negative is equal to positive r, so you're left with r factorial. And then this one just stays the same, n minus r factorial. You see how they're exactly the same thing? The only thing that's different is order, and when you multiply, order doesn't matter. I've proven it. Q, E, D. All right, last question. Solve each equation. So again, what I would do if I was doing this, and I am doing it right now, is I would write this using the combinations formula. So this would equal n factorial over n minus 2 factorial times 2 factorial, and it has to equal 15. Now, since I have an n factorial on top and an n minus 2 factorial on the bottom, do you remember how I can rewrite this so I can cross some stuff out? I could write that as n times, what's 1 less than n? N minus 1. Should I put a factorial? Not yet. What's 1 less than that? N minus 2. Perfect. N minus 2 factorial. All over n minus 2 factorial. What's 2 factorial? 2 factorial is just 2. 2 times 1 is 2. Equals 15. This is good news because this crosses out. What should I do with the 2? Why don't I multiply both sides by 2? Multiply this side by 2, multiply this side by 2. These 2's will cancel. So what I'm left with now is n minus 1 equals 30. Okay, at this point you could use guess and check, right? You could put a number in for n. I'm going to put 5, and 5 minus 1 is 4, and 5 times 4 is 20. Well, it didn't work, but I'm pretty close. I could probably get it in another 3 seconds or something. But the other way, more mathematical, kind of fun, is to expand this, mountains, right? N times n is n squared. N minus 1 is negative n. And since this is a quadratic, remember how we solve quadratics? We make it equal to 0, so you'd want to move the 30 over. It would become minus 30. It's now equal to 0, and then we factor. So we're looking for two numbers that multiply to 30 and subtract to 1. There's a 1 there. What are two numbers that multiply to 30 and subtract to 1? 6 and 5. So it still equals 0. The first thing in each bracket has to be n and n in order to get the n squared. I said the numbers were 6 and 5. Drag down the first sign. A negative times a what equals a negative? A negative times a positive. Now you can use the zero product property. Either this bracket or this bracket equals 0. If you get 0 when you multiply them, the one of them has to be equal to 0. What would make this one equal to 0? If n equals 6. What would make this one equal to 0? if n equals negative 5. Finished. Wait a minute. One of those answers I don't like. Which one? Negative 5. You can't have negative 5 things and choose 2 of them. That makes no sense. It has to be a positive number, or it could be 0. But it doesn't make sense to have negative. So my answer is 6. If you're not sure, try it. Do 6 choose 2, and you'll see that 6 choose 2 is definitely 15. Okay, this one. What's this mean? Do you remember that is there? This is the other way of writing that. Okay, it's just another way of writing it. So again, let's put it in this form. We have 6 factorial over 6 minus r factorial, and then r factorial equals 15. Okay, this one's a little more difficult. We're going to have to just guess on this one. First of all, I can figure out what 6 factorial equals. That's 6 times 5 times 4 times 3 times 2 times 1. That equals 720. Equals 15. Let's multiply everything by this bottom part here. 6 minus r factorial times r factorial. So that'll get rid of it here and it'll all come up here. So we'll have 6 minus r factorial, r factorial. Okay, I multiplied both sides. If you want me to show that step, I multiplied both sides by this. So here it cancels, and on this side I just get exactly what I've written here. Okay, now what I can do is I can divide both sides by 15, and if I do that I get 48, and this at this stage you're just gonna have to guess, but come on, it can't be very big. What's the biggest number you could put into this r? Remember, you can't take factorials of negative numbers. The biggest number could be a 6. So your options are either 1, 2, 3, 4, 5, or 6. So if you put 6 in there, you get 6 minus 6 is 0. 0, the factorial of 0 is 1. Does 6 factorial equal 48? No, it doesn't. So we know it's not that one. 5, put 5 in there. 6 minus 5 is 1. 1 factorial is 1. Does 5 factorial equal 48? No, I think that's too big. Okay. 4, let's try 4. 6 minus 4 is 2. This sounds promising. I'm gonna actually try this one. I'm gonna try 4. Okay, so I have 6 minus 4. This is like question mark. Like, does it equal? I'm testing it. And then I also put 4 in here. So 48 equals question mark. 6 minus 4 is 2 factorial, and then 4 factorial. 48 question mark. 2 factorial. 2 times 1 is 2. 4 factorial, that's 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is still 24. Does 2 times 24 equals 48? It does. It worked. So we now know that 4 is the answer. But wait a minute. Before we stop and congratulate ourselves, if 6 choose 4 works, then what else has to work? 6 choose, do you remember from what we talked about right up here? Choosing 4 things that we're interested in is the same as choosing 2 things we're not interested in. So 2 has to also work. So if you want, you could go back and prove it to yourself and try 2, and you should see very quickly that if I put 2 in here and 2 in here, I would get, so this is 2 and 2, I'd get 6 minus 2 is 4 factorial, and then 2 factorial. We had exactly the same thing, it's just the opposite way around. So yeah, that would definitely work as well. So careful, you actually have 2 answers here. This was not the case over in this one over here, because we were looking for the first number. It's when you're looking for the second number, the r value, that's when you'll have 2 different values. Okay? Alright, that's it for combinations. Well, actually it's not true. We'll do some more, even more difficult ones next day.